Right, question 6. Right, with question 6, so we're given the equation of line L1, which is y is equal to 3x minus 2, and we're given that the line of L2 is 3y minus 9x plus 5 is equal to 0. So what you need to make sure that you understand here is that whenever you have an equation of a straight line, so whenever it is something of the form y is equal to mx plus c, the m that you have stands for the gradient, and the c, if you remember, that's the y-intercept. Cool. Now, for those two lines to be parallel to each other, so if I want line L1 to be parallel to line L2, well, they need to have the same gradient. So line L1 and line L2 will need to have equal gradient for that to be parallel to each other. So if I work out the gradient of line L1, well, line L1 is actually quite easy. Line L1, if I look at the equation, is y is equal to 3x minus 2. So I can see that whatever I got in front of the x, that's what's going to be my gradient here. So the gradient for line L1 is 3. Now it's a little bit harder with the next one. Well, let's think about why. To work out what the gradient is, it needs to be in this form here. It needs to be in terms of y. What I've got here is not something in terms of y. I've got 3y minus 9x plus 5 is equal to 0. I need it to be y is equal to something for me to be able to identify what the gradient here is. So what I'm going to do with this equation here is I'm going to change the subject. So I've got 3y minus 9x plus 5 is equal to 0. I'm going to move everything over and just leave the y on its own. So I'm going to move the minus 9x and the plus 5 as well. So if I want to move the minus 9x, I need to do the opposite of it. So opposite of minus 9x is just add 9x. So I'm going to add 9x on both sides of the equation. So that's going to give me 3y plus 5 is equal to 9x. And I need to get rid of the plus 5. So if I want to get rid of the plus 5, I just need to do the opposite of it, which is taking away 5. Right, so I'm almost done. So I'm just going to have to write this underneath here. So 3y is equal to 9x minus 5. The last thing I need to do to get rid of the 3 here, well, because I have 3 lots of y's, so 3 times y, the last thing I want to be doing is dividing it by 3 on both sides of the equation. So if I divide by 3 on the left hand side, I get just y. And if I divide by 3 every single term that I've got here, so 9 divided by 3 is 3x, and minus 5 divided by 3 is minus 5 over 3. And that's perfect because I can now see that the gradient of line L2 is exactly the same as the gradient in line L1. So gradient is also 3 here. So that's for line L1, that's for line L2. And because they have equal gradients, as the gradients are the same, the two lines are parallel to each other. So I'll let you write that down, and we're going to go on to question 7 now. So the main thing that's really important about this is that you just need to remember your y is equal to mx plus c. Remember that the m stands for the gradient and the c stands for the y-intercept, so where it crosses on the y-axis. Right, cool. Let's jump over to the next question. So question 7. Alright, so let's read this question carefully. So we've got 10 boys and 20 girls in the class. So 10 boys and 20 girls in the class. So the mean mark for all the class, so that's boys and girls included, is 60. And the mean mark for the girls is 54. So that's just for the 20 girls that we have. And the question here is work out the mean mark for the boys. Cool. So, well, the first thing I need to know is I know that the total number of students I've got is 30. And from the first information that I have, so the mean mark for all the class is 60. So what that means is that starting from boy 1, then boy 2, all the way up to boy 10, and then also including the girls as well, so girl number 1, girl number 2, all the way up to girl number 20. All of these students, so all 30 students all together, when I divide it by 30, that gives me 60. It gives me an average of 60. So that's boy 1, boy 2, all the way up to boy 10, and then girl 1, all the way up to girl 20, will give me an average of 60 when I divide that by 30. Now, I want to work out the total score. I want to work out the total score for each of the students, starting from boy 1 all the way up to girl 20. So, what I can do here, so starting from boy 1 all the way up to boy 10, and including the girls as well, if I want to work out the total marks for all of these students, I just need to do 60 by 30 here. So if I do 60 times 30, that's going to give me 1,800. So what that means is that all of those boys and all of those girls, all included, their total score is 1,800 marks. That's what they got. So that's for boys and girls included. Now, what I'm now going to do next is I'm going to work out the total scores for the girls. Now, looking at the question here, the mean mark for the girl is 54. So, from girl 1 all the way up to girl 20, so that's 20 students altogether, the mean mark is 54. So, if I want to work out just the total score for the girls, I'm just going to do 54 by 20, which is going to give me 1,080 marks. To work out the total scores for the girl. Now this is really important. Those two things that I've just worked out, they're essential because I've got the total score for boys and girls, and I've got the total scores for just the girls themselves. Now, like I said, what we need to now do is we need to work out the total score for the boys. So what's that going to be then? Okay, I've got the total score for boys and girls included. I've got the total score for just the girls. If I want to know what the boys have scored, well, it's just going to be the difference between these two values here. So the difference between these two values, so I'll just do it over here. So 1,800 minus 1,080 is 720. So that here is the marks for the boys from boy 1 to boy 10. And because I've got 10 boys, as it says in my question, all I'm going to do is 720 divided by 10, which will give me my answer as 72. Right, good. So question 8. Question 8 is very simple actually. Question 8, I've got 7.97 times 10 to the power minus 6. So So 7.97 times 10 to the power minus 6. The number that I have on the top here tells me whether I need to move the decimal point forward or backwards. If it's positive, I'm moving it forward. If it's backwards, I need to move it back. So if it's negative, then I need to move it backwards. So in this case here, I've got a negative number. I've got minus 6 here. So that what that means is that that decimal point that I've got here, well, it needs to move back 6 times. So 1, 2, 3, 4, 5, and 6. So that decimal point needs to move back 6 times, and I'm just going to fill in the rest. So it's going to be 0.0, and I'm going to just double check it as well, making sure I've got it right. So 1, 2, 3, 4, 5, 6. So that's my final answer, 0.0000797. If it was positive, just remember, if the power on the 10, if the index number was a positive number, you would have to have moved the decimal point forward. But because it's backwards, we're moving it back. Right, so question B. This is also something that we've also done in lesson as well. First thing I'm going to do is I'm going to put that into a fraction. It's just much easier to look at. So I got 2.52 times 10 to the power 5 over 4 times 10 to the power minus 3. Okay, so nice and easy to look at. So right, I'm going to do two things here. The first thing I'm going to do is I'm going to divide those two numbers together. So I'm going to divide 2.52 by 4. And the second thing I'm going to do here is I'm going to do 10 to the power 5 divided by 10 to the power minus 3. Now, let's do this one first. So 2.52 divided by 4. Well, one of the ways that you can actually work this out is, well, it's over 4. I'm going to halve it. So 2.52 divided by 4, that's the same as 1.26 divided by 2. All I've done here is I've halved the top and halved the bottom. And 1.26 divided by 2, if I work that out, that's just going to give me 0.63. Now I don't need to do anything with this because all of what I've done here are all equivalent fractions. So I've divided it by 2 to give me 1.26 over 2, and 1.26 divided by 2, so what's half of 1.26 is just 0.63. Good, so that's the first part of my answer. Yeah, zoom in, yeah. Thank you, miss. There we go, cool. And the next one I'm going to do, so I got 10 to the power 5 divided by 10 to the power minus 3. So just remember that when we're dividing, what do we do with the powers? Well, we take it away. Now just be careful the way you take it away here, because we got 5 minus 3. So if I got 5 minus 3, that's going to give me 10 to the power of 8. And I'll just show you why here. So 5 minus 3, when I have two negatives side by side, that gives me a positive. So it's going to be 5 plus 3, which is 8. Okay, so that's 10 to the power of 8 here. Cool. Now, just make sure that you understand that this is actually not your final answer. The reason why this is not your final answer is because you need to give your answer in standard form. When you give your answer in standard form, it's made up of two parts. The first part has to be a number between 1 and 10. It's not the case here. I've got 0.63. So I need to change this. So right, so 0.63, I can actually change that to 6.3 times 10 to the power minus 1. The reason why I can change it this way is because what I've just written here is exactly the same as what you got on the top there. If you think about it, 10 to the power minus 1 basically means that we're moving the decimal point back to the 6. So back to what this was initially. then times 10 to the power of 8. And finally, to finish this off, when we multiply powers together, we need to add the numbers, so it'd be 6.3 times 10 to the power of 7. Okay, cool. Let's go to question 9. So question 9. So let's look at what we've got here. Right, so Joe buys a washing machine, 20% VAT is added, so that's very important. And now the total, so the cost of the washing machine is now £600. Right, so let me just show a little diagram of what's happening here. So you've got your washing machine, that's your washing machine there. It's initially worth 100%, but because of tax, which is 20%, so this is tax, sorry, tax, the whole thing now is worth £600. Sorry. So you've got 100% here, which is what it was initially. Then because of tax, 20% VAT was added, so I'm going to add on 20% more onto this. And now the total cost of the washing machine is now £600. Okay, so that's actually really important because I've just identified that £600 is 120%. And what the question is asking me to work out is work out the cost of the washing machine, but without the tax being added onto it. So it's asking me to work out 100%. So work out the original cost. Now, to go from 120% to 100%, there's actually no easy way of doing it. There's no one calculation that you could actually, an easy calculation that could actually go from here to there. What I could do instead here is I can work out what 20% is, because I know that to go from 120% to 20%, I just need to divide it by 6. And if I can work out what 20% is, then it's much easier to work out what 100% is after that. Because to go from 20 to 100%, I just need to times it by 5. So whatever I'm going to do on here, I'm going to do the same thing on this side as well. So I'm going to divide my answer, so my question here, by 6. So that's £100. So that's what 20% is. And then I'm going to times it by 5 to give me my value before the tax was added. So that's £500. By the way, there are multiple ways of doing it. You don't have to go with 20%. What you could have actually done here is you could have divided by 12 to work out 10% and then times it by 10. You just need to find a strategy that works for you here. A strategy that can go from 120% to 100%. Right, the reason why I divided by 6 is because I know that to go from 120 to 20, well, 20 goes into 126 times, and that's the reason why I divided by 6. And again, if I divide by 6 on this side, I need to make sure that I divide by 6 on that side as well. And to go from 20 to 100, you times it by 5. Right, good. So let's have a look at question 10. So question 10, so I've got x plus 1, x plus 2, and x plus 3. So I need to times this I need to times this bracket by this bracket, and then by this bracket again. When you do something like this, try to think about how you would work out 2 times 3 by 4, right? Because that's basically essentially what you're trying to do here. When you work out 2 times 3 times 4, what you normally tend to do here is you normally work out the first 2. So you do 2 times 3 first, which is 6. And then whatever your answer is, you then times it by 4. So 6 times 4 is 24. That's pretty much the same method that we're going to be using here. I'm going to work out the first 2, first of all. And then whatever my answer here is, and I'm going to times that by the final 1. Okay, so let's do that. So let's do x plus 1 times x plus 2. Right, so I'm sure you've done millions of them already. So you do x times x, which is x squared, x times 2, which is 2 lots of x's, 1 times x, which is 1x, which is x, and finally 1 times 2, which is plus 2. I'm going to simplify this down. As I can see that I've got 2 lots of x's and 1x. And if I simplify that down, that's going to give me x squared plus 3x plus 2. Okay, so the 3x again, that comes from adding up those two terms together. Now we're not done yet. So this is my answer for the first two brackets, and like I said, once you got your answer, you then need to times it with the final one, the same way we just worked it out. So here I worked out that I was sixth, and whatever the answer here, I need to times it by the final number. Okay, so let's do that. So x squared plus 3x plus 2, and I need to times that by x plus 3. Right, good. So let's do it step by step. So I'm going to do the first term first. So I'm going to do x squared times x, which is x cubed. Then x squared times 3, which is 3x squared.